Welcome, everyone, and thank you for joining us for this panel discussion on powering next-gen applications with embedded graphs. My name is Meryl Lee, and I'm part of the webinar team here at Neo4j, and I'm joined by a very distinguished group of panelists today. Before we get started, I wanted to go over a few housekeeping items. We invite you to submit any questions you have throughout the presentation using the Questions tab located at the top of your screen. We'll answer as many questions as possible at the end of today's session, and if we don't get to them all, someone from Neo4j will reach out to you directly, or you can send an email to webinar@neo4j.com, and we'll get you pointed in the right direction. I also want to let you know that the session is being recorded. With that, I'll go ahead and hand it over to Dave Packer, who will be the moderator for today's discussion.
Great, thank you, Marilee. Appreciate the intro there. Today's session on embedded graphs, I'm fortunate to have three great panelists with us today. Justin Bursich from Lucinity, Ernie Ostick from MANTA, and Caleb Chalmers from Capgemini. And today's session is really about how organizations are reinvigorating, re-innovating, and creating technologies that leverage graph to provide better outcomes for their customers, really evolving where graph is going into their technology stack so that they can embrace the greatest in analytics, AI, machine learning technology, and the rest to really help get ahead and, again, help their customers solve some really tenuous data challenges within the enterprise today. So with that, I want to first hand it off through the panelists here and let them introduce themselves, their companies, and what they're doing today. So give everybody a little bit of context of how they are building with graph and what they're doing. So I'll hand it off to you first, Justin.
Great. Thanks, Dave. And thanks, panelists. Nice to meet you all and talk to Neo4j again. So my name is Justin Bursich, and I'm the head of AI here at Lucinity. We're based in Reykjavik with offices in Brussels, New York, and London. At Lucinity, we're really about improving our customers' defense against money laundering and fraud and other types of financial crime. My job is to really execute the artificial intelligence strategy that we have to really detect complex money laundering activities and other types of financial crime and bring them through to our customers and our clients so that they can investigate them further and actually determine whether these are relevant for submitting to a regulator. So we see our mantra really at Lucinity is about making money good. We want to change the conversation around compliance so that as a society we come together and actually tackle money laundering. And we see graphs in our partnership with Neo4j as a key part of that to really delve into complex transactional data and active data and find these really complex cases of money laundering that most relational databases find difficult to detect with it. So our business model is really around building what we call our human AI platform. And this is about synergistically bringing together the best of human intuition and creativity with the computational power of machines and building trust within one another. We see that when a human understands an artificial intelligence decision, that they gain more trust in that AI and they can actually feed back more information into it. And this manifests into our product. So our product's really about connecting with our clients, which are financial institutions, and connecting through our API. We have very much customer-centric APIs where our clients ingest data into our platform. It's run through several behavioral AI detection models to detect different types of money laundering. And we also do a dynamic risk assessment where we look at actors and customers of our customer and determine whether they're potentially conducting financial crime. And graphs really sit at the core of Lucinity. It's really about leveraging the expressive power of graphs to find hidden relationships, to find illicit nodes, and to find bad actors, and really help our clients bring that through to the regulators. And very importantly on our platform is our case management system. So anti-money laundering it's a very time-intensive task. So compliance teams around the world spend a lot of time going through different alerts of money laundering activity that are being brought forward by systems. And we believe at Lucinity that these people and these investigators need help. They need a hand. And using graphs to actually show money laundering networks and to show illicit actors, this is what really helps them complete their job correctly, efficiently, and productively. And ultimately, everyone together works well, and we can stop money laundering. So at Lucinity, we're really founded on this principle that graphs are the future. And this is, again, basically our mantra, that all information and all shared intelligence in our company is kept within a knowledge graph. And our knowledge graph is stored on Neo4j. And what we do in our knowledge graph is basically hold all the regulations, compliance documents, all types of money laundering regulations that are out there. We hold them within our network, within our graph, excuse me. And what we do is we use artificial intelligence algorithms to traverse through the graph to pick up that money laundering behavior and actually go and try and detect it in our customers. And when we raise a case of money laundering, we can basically use graphs further to, as I said, investigate the money laundering case and other elements of artificial intelligence like explainable AI to actually show the investigator why we found this to be money laundering. So we see graphs as a key future part of Lucinity and generally the future of financial crime detection. And we're very happy to be partnering with Neo4j and going on this mission together to make money good. So I'll hand it back to you, Dave. Thank you.
Great, thank you, Justin. And next up, Ernie Ostick from MANTA. He's the Senior Vice President of Product there. And Ernie, tell us a little bit about MANTA and what you are all doing.
Thank you, Dave, and thank you for all of the other panelists and all of you for attending. Here at MANTA, we provide a unified data lineage platform. And this platform is all about discovering how data is flowing through your enterprise, where it comes from, where it's going to, and what happens to it along the way. We're very excited about partnering with Neo4j because it's enhancing our ability to deliver this capability and functionality to our customers. Ultimately, we help our customers achieve regulatory compliance and enhance their governance activities and speed up the migration process, particularly if they're moving database applications up into the cloud, and shorten their delivery cycles in support of data ops and really understanding the pipeline that they have and how data is flowing and make sure that that pipeline stays reliable. We provide end-to-end lineage. Now, end-to-end lineage means encompassing all the processes in the organization, the places where data is dropped and stored, data warehouses, data lakes, data marts, the mainframe files that perhaps are getting processed through ETL tools, getting loaded into Hadoop, processed by stored procedures in Hive and other relational databases, maybe being placed up into the cloud and then being acted upon by business intelligence tools. And the ability to look at all of those relationships and how that data is flowing makes storing it in a graph incredibly important because there's so many relationships and they're very complex. But that's what we do in providing our customers the ability to view their lineage from end to end. How do we do that? Well, MANTA actually goes through and looks at your code. We crunch through, we like to say, that code, whether it's SQL statements, whether it's the complex information in various ETL tools, or it's the metadata provided by reporting tools, such as Tableau and Cognos and ClickSense, all these different offerings, and looking through that in detail, and then documenting the lineage along the way. How does this column flow into that table? How does this procedure read that particular one and load it somewhere else? Or how is it defined in a view? And finally, out to the front ends where people need to actually trace that lineage going upstream. And then we visualize that lineage with an interactive map, ultimately pulling that information from the graph database, but then displaying it so that it can actually navigate and look through all of these different procedures to drill down and see the individual transformations that are affecting my data and understand where it goes for many different use cases, as we outlined before, from compliance through actually supporting your upward flows and keeping them in production and rolling along. Thank you, Dave.
Great, thank you, Ernie. And lastly, Callum, he is the Senior Data Scientist at Capgemini. And tell us a little bit about your business and what you're doing there at Capgemini.
Thank you, David. And hello to the people on the panel. Very nice to meet you. So yeah, as they've mentioned, I'm a senior data scientist within Capgemini. And Capgemini, we're a global leader in consulting, digital transformation, technology and engineering services. The group is at the forefront of innovation to address the entire breadth of clients' opportunities in the evolving world of cloud, digital, and platforms. Capgemini is guided every day by its purpose of unleashing human energy through technology for an inclusive and sustainable future. We are a responsible and diverse organization of some 270,000 team members spread across 50 countries. I'm based here in the UK, very lucky to be up the road from birthplace of William Shakespeare, a very nice part of the world. With a strong 50-year heritage, of course, and deep industry expertise, Capgemini is trusted by its clients to address the entire breadth of business needs, from strategy and design to operations, fueled by the fast-evolving and innovative world of cloud, data, AI, connectivity, software, digital engineering platforms, and of course graphs, which is why we're all here today. Thanks, Dave.
Sure thing, and thank you, and thank you all for introducing yourselves and your companies. A lot of interesting things going on for sure. Let me start off by, there's a lot of fascinating use cases that are obviously evolving. That graph is kind of opening the doors to new ways of approaching things. And Ernie, maybe start with you. There's obviously a set of customer challenges, and then there's graph technology and kind of, the bread, or what do you want to say, the pieces that come together, or the stack you're building for your customers. And, how are you, is it helping you address those challenges? And how is it different than what was there before, right? Because obviously some of these things aren't new. People were trying to do them before, maybe with other technologies or whatever. What's the big advancement that's happening to help address your customers' challenges?
In particular, there's a couple of reasons why we went with Neo4j, but I would say perhaps the most significant is being conscious of the performance that we're going to need as our customers go from tens of millions of objects that they're trying to track in lineage to hundreds of millions or perhaps more objects than that. And performance is absolutely critical. We go through this parsing and crunching mechanism that I mentioned, and then we have to load that information somewhere. And a big part of that whole function of parsing someone's environment takes a long time just for our own technology to be applied. So we want to shorten the time as much as possible to then make that information useful. So being able to load the graph as fast as possible is critical. Mm-hmm. But then it's only good to a point, because now you have to turn around and take advantage of that and display it in that tooling that lets you examine the lineage up close. And so retrieval and search capabilities and being able to do those in an incredibly performant fashion is important. So we anticipated from our largest customers the kind of growth that they would have. And this was our reason that we felt we needed to go with a much more powerful underlying chassis, if you will.
Yeah, so it's interesting, performance, scale, all those things that all have an impact on the overall outcome at the end of the day. And, like you say, data growth is so extensive today, right? And so many different inputs coming into the business, and, everybody's a data-driven company today. So obviously, the better that you get at managing the data, especially the lineage of it, which I can only imagine how complicated that must be as businesses grow, and especially your clientele, right, which is financial and other companies of the such. So, Justin, how about you? What's your take on, obviously, heading up AI at Lucinity and being responsible for that, machine learning, big technology that's been emerging for a few years now. It's taken a few years to get where it is. But how does that question pose to you in the sense of what you guys are doing?
Yeah, no, it's a very interesting question. And, I just want to just sort of re-emphasize as well what Ernie's saying with this huge amount of data coming onto platforms. We're all used to it. We all know which direction the world's going in. And, at Lucinity, for example, we can work with some customers with millions of transactions a day. And I think what's happened over the last couple of years is, as AI has advanced, AI is really about respecting what's called the multi-dimensional nature of data. That lots of different data points in our world connect in very complex ways to explain things. And if we look at a relational database, or if we look at kind of almost the old way of doing things, it's more respect about, hey, here's a single data point and here's another data point. But we need to think about the connections. Now, as AI advanced over the last couple of years, our customers were faced with the challenge of more and more data. So a single transaction conducted at a bank, there may be 30, 40, 50, 100 different data points about that transaction. Now, you add the complexity of thinking about connections between different transactions, between different people, between different customers of banks and financial institutions, and this amount of data just explodes. So I actually think that the graphs are a way to actually simplify things. It's actually around, hey, we don't actually need to create this complexity. Let's put it into a graph and let's run the algorithms or the queries or whatever that we need from the graph and extract that intelligence and those insights. And I think that's a great innovation. We're going back to our roots of kind of simplicity, but the power of building brilliant intelligence from it. So, at Lucinity, it's really about our customers' challenges. We want to empower them to fulfill their compliance function. Compliance is a difficult task. Banks spend a significant amount of money on compliance, and generally, it's not the easiest. It's not a cost center it's more a cost center of a bank than a revenue generator. And empowering these guys with the tools to really perform their jobs is key. And graphs really help us and help us go those extra steps to build the actionable intelligence and insights that they need to do their job. So it's a key part, and it's actually very exciting to see the trajectory and growth over the next few years.
Yeah, it's fascinating. I want to double click on the comment you made. I will after get Column's input on this, but the ease element. Obviously, it's interesting when you think about transitioning to graph and going that direction, and the simplicity it could introduce, but it can also seem like it's not simple at the same time. So I want to come back to that. But Callum, what in your world, how do you see both the customer challenges and utilizing graph to really drive success for them, and how has that changed your orientation into what's happening?
I think I agree with what both Ernie and Justin have said, but I guess just to kind of really pick up the one thread, and that's for me, or Capgemini, it's really about the interconnectedness of data and data relationships. Obviously, data volume and data quantity is certainly one issue, but for me, it's really that uncovering relationships that were perhaps hidden. So yeah, a good example to my mind is obviously we've all been affected by the COVID-19 pandemic, and clients have been trying to solve a wide range of issues related to that. And I guess an obvious challenge that has caused is obviously healthcare issues. But it's not just healthcare. It's like there's also logistical issues. It's getting the resources to the right places, vaccines and so on. And so all these connections, it's not just about healthcare per se. It's all the follow-on issues. We also see very similar threads to that. Obviously, when detecting fraud, fraud and financial crimes are obviously. It's all interconnectedness, relations between people, who's leading a criminal gang, who's posing a security threat. It's who they know, where they've been to as well, or what communication channels that have people been involved with, and I guess following the money is another issue. That's all to do with it, the whole interconnectedness of data.
Mm.
I think another slight spin on it is also, and perhaps something that we don't think about enough of is, the time dimension of data. The temporal nature of how data and graphs evolve over time. So we're certainly seeing clients faced with challenges in predicting, modeling future events. It's not just about the here and now. It's what's coming up. So again, using COVID as an example, it's modeling future outbreaks potentially, or modeling the transportation of vaccines from one country to another country and so on. So those are the sort of issues that we're seeing.
Yeah, that's interesting. Especially COVID, obviously, Neo4j has been utilized a lot from a graph perspective in helping to kind of map out, spread and all sorts of interesting, research use cases and things like that, which has been fascinating. I think sometimes when you're, in a technology company, you always want to see your technology being used for the good of improving the world somehow, right? And that's definitely been an area where it's been fantastic to just kind of see some of the things that have fundamentally helped companies, make a difference and do, especially under the COVID crisis. And so, Justin, I want to come back to you on the conversation we just had a moment ago. And, one thing that obviously, developers, as folks like yourself, you're building, is the ease of graph, right? Like, at first introduction, it might seem almost intimidating, right? And then there's like, well, I've got to learn how to use it and embed it into my system and develop on it. Like, tell me a little bit about your experience there, and what was that like bringing in Neo4j and working with it and kind of getting up to speed and learning about graph and all those pieces.
Yeah, it's been a great experience, a very interesting experience. It is a very interesting technology to first encounter. The concept of nodes and relationships being its fundamental elements, and then what can we do from that? Where can we go from that? And the fact that I think Neo4j has, both with Cypher as the query language, both with how relatively easy it is to integrate data in, has made that experience actually quite enjoyable. I think the data integration into Neo4j is, from a developer perspective, from a data engineer perspective, you have an easier and you have a more rational way of dealing with and building up your data that you ingest into your database than you do with a relational database. Of course, in a relational database, you have your data points, your connections, but in a graph, you're actually looking at a behavior or basically a reality in a way, and how everything connects. And in terms of experience of connecting, there's always complexities with how data is held. We hold, through our APIs, our data model ingests very well into Neo4j and very efficiently. And as well through basic, table or CSV imports or things like that, it's also very, very easy to connect. But I think what sets Neo4j apart a little bit is the ease of queries and the speed of queries deep into graphs. So, especially from a data science perspective and from a money laundering perspective, we're interested in very deep criminal networks. Sometimes you'll see a transaction go around the world 200 times and end up in a bank in Panama. And that's the transaction that you need that can trace back all the way to a criminal ring. And the ability to actually ingest all this data through, and as Callum said around the temporal component, to ingest it over time and actually see how the data develops over time, and to pinpoint those criminal networks is actually very, very interesting and obviously enjoyable experience to help clean up the financial system. So I would say all our developers enjoy working with it, especially Aura. Aura is very easy to pull, very easy to scale up, scale down. But in essence, it has been that new approach to thinking, nodes and relationships that's changed obviously from how things were done. So, yeah.
Oh, that's great. Really it's interesting because I know even my own experience when I first learned about graph, I was thinking, how do I get my head around it or initially, right? And that's but I also find that the amount of resources out there and everything else really made it easy to kind of like shift that thinking, almost like going from procedural program to object-oriented programming. There's always that first hurdle, but once you cross it, then you're like, oh, why would I have done it the other way? Right? So how about you, Cal? What's your take on that? And kind of like, obviously you're working with a lot of different customers, a lot of different use cases, helping build a lot of different kind of stacks and technology solutions. So how about your teams?
So, and for me personally, I absolutely love Cypher and sort of graph technology. I think that comes back to my sort of mathematical days. I loved graph theory when I was at university. So it was nice to actually, it was nice to kind of see, those sort of abstract concepts, that are written in deep mathematical prose kind of, it really translated to, a very visual thing. So for me, it was very nice. But I guess one of the things we love about, I guess, graph modeling and designing, I guess, as it were, the schema, if you want to call it that, is, you just take a whiteboard, you draw out, how the relationships in between, entities exist, and that is your data model. So yeah, it's very easy to build data models with Neo4j or with graph databases more generally. The visuals are also very powerful. Graph visuals, whether it's through Neo4j's Bloom visualization platform, or of course you partner with them as well. The platform from Lincurious, that's a great visualization as well. So we've been using that for a number of use cases. So I guess, yeah, it's been a joy to work with, actually. Nice to see in action.
Yeah, great. That's great to hear. How about you, Ernie? I know you and I, when we first met, you spent some time explaining to me your kind of developers and kind of their embracing graph and everything. Like, what's that experience been there with your team?
Well, interesting. We actually made the transition to go with graph good number of years ago now, from relational, because clearly in this area of metadata management and lineage, just the number of relationships is, overwhelming, and graph was clearly the way for us to go. And then doing our analysis on our customers and where they're headed, we just realized that the open source graph choice that we had made several years ago, which was good at the time, was not going to, meet the needs of our customers and how they're growing right now. And I think to go back to the ease of graph, I'll point to our engineering discussions about the ease and maturity in particular of the Neo4j portfolio. The extensive, graph is out there, but the extensive networks that are available, not just with Neo4j teams themselves who have supported us wonderfully, but just overall within the industry that are talking about the techniques they have with Neo4j, providing support for those things that we need. And what does that do? That translates into faster time of value for us to get to a full Neo4j implementation, but also promises a whole lot more things in confidence that we can support our customers. And that's critical as well.
What kind of difference has like the community made for you all? In the, obviously, somewhere around 200,000 developers out there in the community. Has that been super assistive to your team there, Ernie?
Yeah, absolutely. They remarked how they were easily able to get answers, even if, time zones weren't exactly cooperative, and there's always new advice and wisdom that comes from some creative solution,
Right.
that a Neo4j customer happens to be playing with, that may just be another creative way of implementing an API or a particular model.
Mm-hmm. Yeah. The one area that's obviously interesting is kind of where you see graph going, and there's all these bets about graph is going to be the next big database, and it's going to dominate just because of a lot of the things you folks have talked about. Growth of data, machine learning, all these different use cases, and I think also just a lot of use cases companies discover as they start using graph more and more, right? Ernie, from your standpoint, where do you see graph going? Like, how do you see it maturing over the next, 5 years? And how do you see that affecting the whole data landscape out there?
I've been impressed by the uptake of a broader set of users. Going back a ways, those of us that like to tinker, certainly the deep engineers that all of us have within our organizations, we're certainly, starting to use graph because they saw its popularity. But it's getting out to a greater population. Now, exactly what methods people use for doing queries against the graph database, is everybody ready for that? Maybe not yet, but maybe as that part of it matures, we'll start to see a larger number of users perhaps getting towards the more less technical that are feeling comfortable diving into the graph with obviously tools that are going alongside of it. But I would say that that's probably the biggest thing I'm seeing, is that the audience for accessing the graphs is enlarging.
Right. Well, I think especially in the last year, there's been quite the shift that we've seen just in adoption and interest, and as data science continues to mature, that area, we've seen a huge increase in interest from data scientists on graph and everything else. How about you, Callum? How do you see kind of the next few years and where graph is maturing to?
I think I certainly agree with Ernie. I mean, we're seeing obviously a massive uptake in clients just being interested in graphs, and clients that are using graphs that also really begin to push the boundaries of what graphs can do. The kind of use cases become much more developed, much more complex. Particularly with the integration of AI and ML techniques and so on. We're not, in terms of how I see, the graph databases or the sector moving in future, I think one of the things that perhaps has been a hindrance to some clients adopting graphs a bit more is that, technically there are, 3 graph models, but let's put hypergraph and other complications to the side. But we really have the property graph model, such as Neo4j and and others, of course, in that sector. And then we have the resource description framework, or RDF graphs, and it's that what graph model should be adopted for particular use cases. Often they're seen as kind of competing models in some sense. The different strengths and weaknesses, and historically maybe they've been viewed as having different use cases. With RDF graphs, they've historically been used for data understanding, data exchange, semantics, and so on. And labeled property graphs, they were designed for fast querying, storage, with key strengths of fast graph calculations, great use cases for problems that involve transactional data and so on. But I think so there is that which model's kind of best for clients. I know we are seeing developments of the RDF star schema or RDF star model, and so we're kind of seeing perhaps a blurring of the lines between RDF and property, and I wonder whether, you said 5 years hence from now. I would say maybe 10 years hence, will we make a distinction between the two graph models? I don't know. It's a hard one to call. But certainly, I think that's been a hindrance to some people understanding the different types of models.
Interesting point. Yeah, that's a good one, because I think there are, different techs, different ways you can approach it in different models, and it's not always easy to touch like what I'm trying to do and what is the right model and bringing that together. But yeah, I mean, I would imagine at some point you would have kind of like a, Uber model, right? That takes over, that can be used in both, both worlds. But what's your take, Justin? And like, I'm also interested in just like, what do you see is really driving the interest too, right? Are people just stumbling on graph? Is there something in particular that's really making it more interesting to folks and seeing wider adoption?
Yeah, so there's no doubt that we're seeing these conversations more and more. Our customers are actually actively coming to us talking about graphs. And that's happened at all different levels, at the engineering level, at the compliance level, the boardroom level. So here's one take on it. Especially from a developer perspective, there's kind of little bits and pieces in it for everyone, right? So let's just start at the top. You can develop the UI level. You can develop a beautiful interface. We've mentioned a few libraries, but in essence, when you see a graph in Neo4j Bloom or whatever type of technology it's in, you just automatically understand what's happening. It takes a little bit of time to get your head around it, but you see that there is an environment, a world that is tangible, controllable, and you can actually spend your time trying to understand. The graph shows you what is. And then if you go back through, through an organization, through a developer team, you have bits and pieces in there for the engineers, right? It's an interesting technology. It's a big shift from your traditional databases. And that in itself is very interesting and innovative to work with. A lot of relational databases have been around for 20, 30 years plus, and some of the technology has kind of gone into a degree of stasis. So graphs represents an ability to kind of use these new technologies. And then you get right into the deep end, into the data science realm or the AI realm. And I will say that one of the greats, it's a great feeling when you run an algorithm for the first time, some type of graph data science algorithm, and you can automatically detect something that you just know you couldn't find in a relational database. Or if you had built 100 features and a brilliant neural network or whatever type of model, it was just too difficult to find and too complex. So I think when data scientists start to use graph data science tools like community detection, link analysis, and different types of algorithms, you straight away start to extract intelligence and insights that you can't get elsewhere, or it's very difficult to replicate. And I think where we're going, so I really want to touch on Callum's point around the temporal element of data. And I personally see this as the most interesting, one of the most interesting directions I think graphs and graph neural networks will go in. So, a graph neural network is really about uncovering hidden relationships that aren't so evident in a graph, using a neural network to actually detect and predict where a relationship may be that's not so evident, or a node that, for example, may be illicit, or a node that may be any type of supervised learning problem. So the current graph neural networks and graph data science techniques are quite interesting. But I think where the next 4 years and 5 years and the future is going to go is to really develop these prediction models of how graphs are going to transform through time. So if we start to see a certain graph build in a certain direction, where do we predict to be in 3 months, 6 months? How do we expect behavior to change? This is, I think, key for solving a lot of problems. Supply chain, COVID, vaccine distribution, things like this. How do all these complicated, complicated but interconnected variables come together to explain what is happening now and how we think things are going to actually transform into the future? So that to me is really the future.
That's interesting. I mean, nobody can predict when a ship's going to get stuck in the Suez Canal, right? And, and how that's going to impact the supply chains on a global level. It's pretty interesting to read, just like how many companies were panicking, waiting for that ship to get freed up. But I'm looking at the time, and we need to kind of shift over to just some of the questions that have come in, just before I do that, though, are there any other highlights anybody wants to mention? Is there anything that's based on the conversation so far? Nope. Okay, that's good. It means we've covered a lot of good points. Perfect. So let me go into the questions here really quick. And one person asked, SQL versus graph languages. Obviously there's Cypher, Gremlin, GQL, which is an upcoming standard. How has that been, like that transition in learning in that standpoint? Any of you want to go first or talk about that for a second?
I would suggest that it's offered our engineers the ability to do kinds of analysis of the nodes and edges that just either weren't possible in from a SQL perspective, or would have been the most insane queries that it would have just taken forever. And maybe you could create a model that would work for one query, but it's not going to work for the next query. And that was significant. Being able to follow and look at the relationships, or even look at nodes that have no relationship, is extremely important for our customers. And I don't think we just, couldn't have easily delivered that on a relational platform.
Yeah.
I think my experience of the sort of SQL versus Cypher, I guess, I actually think learning Cypher to be actually much easier than SQL. With Cypher, it's a query language that's actually very visual in nature. The syntax is that kind of that ASCII art almost. You've got that text-based visual representation. So I mean that makes the language very easy to write, very easy to read for others as well when you're working in teams. And it's visually and structurally represents the data very well. So the way you put your arrows represents and reflects the direction of the relationships in reality. So actually, I think it's for me it's a nicer language as well.
It's like more intuitive that way, right? Yeah. So, how about you, Justin?
No, I think just the same. It's intuitive, and like Callum says, it's almost like your Cypher code is almost a representation of what your graph's going to look like. You can see the graph forming as you're writing your query. So to be honest, a lot of the last 5 to 10 years, in my experience working, more so with Python and pandas and machine learning type data frame libraries. SQL is something that is, of course, useful for your queries, but it's becoming more and more about doing your queries to bring in the right data so that you can perform your machine learning, as opposed to just writing your whole suite SQL query. So it is the same with Cypher, and it just aids the machine learning process to get the data in correctly and easily.
And do you all see it? It's kind of continues to one question. Like relational databases versus graph databases. Coexisting, one taking over the other. Do you see a point in time where graph databases might dominate over relational databases? It's an interesting question because it actually has come up in other conversations I've had with folks. Thoughts on that?
I think, it's certainly got to be recognized that there has been, consistent growth in the adoption of graph databases over the past decade or so, and there's been various, Gartner reports and predictions, by other commentators, as to, graph being, a real tech innovation and so on. that said, I think it's fair to say, in my view, that graph databases are still seen as a bit niche. And I think we're quite some way off seeing graph databases replacing SQL. I think ultimately we might. I think we'll see them more side by side in time. I don't think we'll ever get to a point where one will necessarily replace the other. I think they solve different problems. So it's I think it's very. I think you use the right tool for the right problem. Is my view on it.
Yeah, I mean, and definitely we see today a lot of coexisting. Hey, I've got these particular problems I'm trying to solve this way. My relational database, tables, rows works perfectly because I don't need to really mine it or understand the context that well. It's just high transaction stuff versus, hey, we really need to understand the deeper layers of information here, right? And understand what's happening and what that means to our business, and even find kind of like the unknown unknowns, right? And the trends and things that are there. Ernie, from your standpoint, how about for your customers and they're, using your technology? Before we kind of close out here, I want to ask this of each of you, just like, has there been a lot of like wow moments, like where your customers are like, wow, this is completely different than we had originally anticipated the outcome on it to be?
Absolutely. I mean, it kind of even blends into the previous discussion because legacy stuff never goes away. And we have customers who are doing bleeding edge things with new kinds of databases and storage in the cloud. And guess what? They still have COBOL on their mainframe with vSAM IMS databases. And there's lots of reasons for that, economical, and if it works, don't break it, that kind of thing. But the reality is that they're moving data from place to place. And there was no way to easily understand this in a quick fashion. And that's probably the biggest eye-opener for our customers, regardless of their use case, right? Whether it's regulatory compliance or it's, oh my gosh, the warehouse didn't get loaded and I've got a screaming executive who needs his report. Whatever the use case that drives it, trying to find out what the lineage was impossible. It was phone calls and emails and running down the hallway and someone's on vacation and, oh, we don't know where that code is. And it would take days, sometimes weeks, or people would give up. And, Lineage and, the platform that the Graph is helping enable lets them get that answer extremely quickly, regardless of what the use case. That's significant in changing people's behavior and, how they support themselves and their customers.
Yeah. How about you, Justin?
Yeah, so I think we've had a very positive experience, especially as you go through the kind of a POC phase with a customer. They'll see things that they didn't expect to see. And it's the same thing with our data science team and our AI team. It's really about, hey, there is this unique feature that's helping us detect this specific type of money laundering, and we can pull it out of the graph with this query. And it's something that it's kind of a light bulb moment to say, hey, it is just this query. It's not these 100 features or this complex model. It is really just about looking at this relationship. And I guess I just want to highlight that, for us, Lucinity is really about behavioral detection. It's really about, finding money laundering behavior. And graphs are the perfect tool to both show behavior and to find behavior. And for that, that helps both our customers and our team, attain better outcomes for our clients. So no, that's been a very positive experience. And obviously everyone enjoys the visualizations.
Yeah, well, that's great. And Callum, how about you? Close it off with your take on that.
No, I absolutely echo the comments made there by Justin and Ernie. I think for a lot of clients, there's been that sort of eureka moment when graphs are so visual, and because they're so visual, they're accessible to not just the technical experts and the data scientists, but you can present and show essentially a graph database, through the visuals to almost any stakeholder, but you would never do that with a relational database. You wouldn't show, a senior executive or whatever, a bunch of tables.
Right.
With relational databases, you've got to tie them into, some sort of, BI platform or whatever to extract some sort of insights and so on. And but with graphs, you don't have to do that. Obviously you can do that as well. But graphs are. We live in a visual world. We are visual people. So I think that's really the sort of eureka moment for a lot of people to see it visually.
Yeah. Well, thank you very much. I appreciate it, and it was great insights. Really enjoyed the conversation with all three of you. Thank you for taking part in today's panel on embedded, and what does that mean to people who are developing and really providing their customer solutions and integrating graph into it. So I just want to thank you all, and we'll just kind of end it here. Appreciate it, and thank you for everybody who attended today's webinar, and look forward to chatting with you all sometime soon in the future.
Right.
Thank you very much.
Cheers, Ed.
Right.
Bye.